This is the solution for third question of homework 9. So in the question we are given a Poisson process n of t with the distribution, and we are asked to prove that the limit t tends to infinity n of t by t tends to lambda in probability. So since n of t is a Poisson process, the nth arrival time is the sum of the first n inter-arrival times. So this is one of the properties of the Poisson process. So let's just for our notation, let t of n equal tn equal to xn plus x2 plus x3 so on up to xn, where each xi is the inter-arrival time, which is exponent, each of which is exponentially decaying. Also, each of them have an exponential PDF with the parameter lambda. So the mean of each of these is 1 by lambda. The expected value of xi is 1 by lambda. So this is also one of the properties of Poisson process, which is similar to like the difference between the two non-overlapping intervals is independent. Now let us take the t, which is between the n of tth arrival and n of t plus 1th arrival. So t is between t of nt plus 1 and t of nt. So we have shown before that notation for t of n of t is x1 plus x2 so on up to xn of t. So now let's divide this term with divide the inequality with n of t. So without any loss of generality, we get t by n of t less than t of n of t plus 1 by n of t. The t of n of t is greater than or equal to t of n of t by n of t. So let us substitute the notation. So the t n of t was sigma I running from I to 1 to n of t xi by n of t, and t n of t plus 1 was sigma I running from 1 to n of t plus 1 xi. So this is the final inequality we get. Now if we apply limit t tends to infinity for all the terms, we get this final expression. So this part, these two, so we have to compute the limit for these two. So as we know from the law of large numbers, so let us for any random variables xi, sigma xi by n as n tends to infinity is equal to expected value of x. So over here xi is exponential, therefore sigma xi by n will have, so limit t tends to infinity, sigma xi by n is equal to e of the expected value of x. The expected value of the exponential random variable xi is 1 by lambda. Therefore the limit of these two will be equal to 1 by lambda. Now so this function t by n of t is sandwiched between these two functions. Therefore limit t tends to infinity t by n of t is also sandwiched between these two limits. Therefore using the sandwich theorem, we get limit t tends to infinity t by n of t equal to 1 by lambda, and if we take the reciprocal we get the required result, which is limit t tends to infinity n of t by t equal to lambda in probability, since we have used the law of large numbers, which converges to 1 by lambda in probability.